Hey guys, welcome to a new video. In this video, we're going to talk about Tesla's neural networks and like how they work, like how Tesla uses neural networks in their cars, and also like what neural networks are and how they use computer vision. Because like Tesla is one of the world leading companies in using like computer vision and deep learning and neural networks in a practical way, and they have this autonomous car here that they're trying to improve all the time by training the neural networks on data that it gets by just driving around in the environment. So let's start with an example here where we can see like the Tesla driving around and doing some detection with the neural networks and computer vision. So this is like how Tesla drives around and does object detection in the environment. Like we can see here that it is now on the highway, and we will turn on autonomous driving here and the autopilot, and then we can see that it detects the lanes here on the road and also like the cars in front of it, and then it can navigate from what it sees from computer vision and the neural networks that they're trained on. So to start off with, we're going to talk about like Tesla's cameras and the sensors they have in the cars, because these are like the most fundamental things they have. So these are like the cameras and the sensors is like all the inputs that the car gets, and then it sends all the inputs to its neural networks that are trained, and then it does some predictions on like the lane roads and also like the cars and pedestrians in the image and stuff like that it detects. So one of the most important sensors or like cameras it has is like the front cameras. So it has three front cameras where we have like this main front forward camera here that has a maximum distance of 150 meters, and we can see like here in the light blue box here, like of this field of view here. So like the main forward camera is used to like detect the cars in front of it, and also like just to like get the most important information from like the environment. And then it also has a wide forward camera, so we can see like more towards like the sides of the front. So if we have like, for example, cars in the left lane or right lane from like the lane we're in right now. And then you also have like a narrow front camera which has the same field of view as the radar that Tesla uses. So these are like the only like sensors like Tesla uses for like detection regarding like cameras and also like radars. So Tesla not using LiDARs, as I'm also going to talk about. But like Tesla uses this narrow front camera here that has a longer distance of 250 meters, and then it has this radar here that can like estimate how far or like how far away other cars are, and also like how fast they're moving. So like they use this narrow forward camera here together with the radar to like detect like the depth of like the other cars in the image, and also like a lot of other different kind of stuff. So like all the forward cameras, like they work together for like extracting different kind of information and then feeding that information to the neural networks. And then they also have like these ultrasonic sensors here like around the car, which has a maximum distance of 8 meters. So these are just for like detection of like close objects close to the cars. So with ultrasonic sensors, they can't see like what objects are close to the car, but just that there's some objects inside of this distance here, and then it can like just like detect if something comes in front of the car or comes from the side of the car. So let's say we're going to make a lane change, then the ultrasonic sensors detects if we're trying to like pull out in the left lane. If there's a car coming up to the left of us and we didn't see that, so then the ultrasonic sensors would spot that together with like the rearward looking cameras as well. So like the cameras to the back, like there's no cameras to the side here of the car, because they don't really care like about what is to the left of the car, because we've already seen all that information with the front camera, or like we can see with the back camera. And then we just have these ultrasonic sensors here to detect if something comes in from the side of the car. And then they have these the back cameras here, where they have the rear camera view here, like the smaller camera here with a max distance of 50 meters to like see what is like right behind the car. And then they have like some longer distance camera here, which is the rearward looking side cameras, which has the maximum distance of 100 meters. So like these are all the cameras, and Tesla uses 8 cameras in the setup here, and they're just all the time feeding information to the neural networks that they have trained on data, and then they're doing some predictions that so that the car can operate in the environment that it's in. So first of all, we're going to like talk about like the basic stuff about like how neural networks work, like just in general. So with neural networks, we have like these neurons here, which are like represented as nodes here, and we have some input nodes here, which could be like the images that it gets in from its camera. And then there's some the hidden layers here inside, and each node has a weighting. So a weighting is like it represents a node with a weight, and then those weights here, they get updated when they train the neural networks on new data. So it gets some inputs here, and then it feeds forward like that information that it gets from these nodes. So the output from these nodes get fed forward to the inputs of the nodes in the next layer. So in like more complex neural networks, there will be like a lot of more hidden layers and other like different types of connections. So this is just like a default, like a standard neural network with one input layer, two hidden layers, and then we have the output layer here. So let's say here we have like an input image here where we want to like predict if it's a dog or cat, and then we have like this neural network that it just goes through, like all the information is passed through, and then in the end we will end up with a prediction here where it could either be like cat or dog. And then we can like train our image here and back propagate backwards in our neural network here, and then update the weights when we train our neural network, so we just get better on more information. So like the more images we get to our neural network that we can train on, like the better our neural network will be and the better our predictions will be with neural network. So this is just like how like neural networks work in like just in general, and we're also going to like talk about like specific what neural networks does at Tesla. So the use of neural networks here at Tesla is like they're using it for like, for example, lane labeling, where they're predicting a path that the car is going to take. So we can see here on the image here that we have a car here, or like a lane here. It takes like these two lane lines. It has to be inside. And then we have like this green area here, which is like the free space that the car can operate in without making any collisions. And then it tries to, like with this yellow line here, it tries to predict some path that it's going to take. And we can see that it also like detects the car here that is parked, and also a pedestrian here and some other cars that are driving. So they have like different types of boxes regarding like what the cars are. We can see here that it has like a blue box here, so it could be like, for example, that the car is now following this car in front of it, and then it's indicated with a green box or blue box and something like that. But they're also using neural networks for like detection of like signs, and also like traffic lights, and like just all of the objects. So they just feed information with all these types of objects and like traffic lights and different kind of scenarios to the neural networks. Like they have tons of neural networks just working together. Like it is not just only one network that is just like running all the time. Like it's multiple networks that are running some kind of like detection or like prediction for each of those categories here, and then like they're featured together, and it will like just like output all of these outputs here in the image. And this is like actually what the Tesla computer sees from its cameras and the radar and stuff like that. So we can also like, it can also be used for like fleet learning, which is like more practical example, where it can like predict if a car is going to cut in front of us, and like if it like changes a bit towards the middle or like towards our lane that we're in, then it can like predict like what the car is like going to do by just learning from like all of the like experiences where a car just cut in front of the Tesla, and then you can like change towards that situation where like it could like brake a bit if that car is like moving a bit over towards our lane and stuff like that. So it can be used for a lot of different kind of things, and it's just all about getting data and getting as much data for a specific situation as well, and then just training the neural network so they get as good as possible. So let's take a look at the path planning and prediction that we talked about here.
You're telling us how to traverse different environments. So what we're looking at here is some person in the fleet who took a left through an intersection. And what we do here is we have the full video of all the cameras, and we know that the path that this person took because of the GPS, the inertial measurement unit, the wheel angle, the wheel ticks. So we put all that together, and we understand the path that this person took through this environment. And then, of course, we can use this for supervision for the network. So we just source a lot of this from the fleet. We train a neural network on those trajectories, and then the neural network predicts paths just from that data. So really what this is referred to typically is called imitation learning. We're taking human trajectories from the real world, and we're just trying to imitate how people drive in real worlds. And we can also apply the same data engine crank to all of this and make this work over time.
So I'm looking at an example here of the cut-ins that we talked about, where Tesla predicts
so you're
like
driving down the highway, someone is on the
us.
left or on the right, and they cut in front of you into your lane. So here's a video showing the autopilot detecting that this car.
So we're not like see when you try to like estimate the distances towards the cars,
of course,
and then
we'd like to detect
if
a
it
cut
cuts
as
in
fast
front
as
of us.
possible. So the way we approach this problem is we don't write explicit code for, is the left blinker on, is the right blinker on, track the cuboid over time and see if it's moving horizontally. We actually use a fleet learning approach. So the way this works is we ask the fleet to please send us data whenever they see a car transition from a right lane to the center lane or from left to center. And then what we do is we rewind time backwards, and we automatically can annotate that, hey, that car will in 1.3 seconds cut in front of you. And then we can use that for training the neural net.
So when we're talking about neural networks at Tesla, like they're using most convolutional neural networks, which is like we use convolutional neural networks when we are operating with images and also like video frames. So we have this input here, which is an image here, and then we have some different kind of layers here. So specific for convolutional neural networks, and when we're using video frames and like images from a camera, then we're often using like convolutional layers together with like something called ReLU, which is like kind of an activation function. So I'm not going like in depth with like all of these like complex things here inside like in the hidden layers. Like I'm going to make a tutorial on neural networks where we're going like more in depth with all of these different kind of layers, like where we have like pooling and we have convolutional networks, and then we have a pooling layer again, and then in the end we have like this classification part of the neural network here where we flatten our image. So we just like have a sequence of like image rows, and then we have like some other different kind of functions that can actually like do our classification, and then the output of our neural network here could be a prediction if it's a car, truck, van, and stuff like that for a given input here to our neural network. So we're going a lot more in depth with this convolutional neural networks in another tutorial, and this is just to give you an understanding of like what the neural network does at Tesla. So Tesla has their own full self-driving computer. Like in the past they used NVIDIA GPUs, but they just found out like it isn't fast enough to like do the kind of applications that Tesla wants. So they developed their own like full self-driving computer, which has 2 chips here on the computer. So both chips are identical, and they just have 2 computers to be like 100% sure that the prediction it does is the best one for the given scenario. So they just have like 2 chips here that are like just compared to each other. Like the outputs for these 2 chips here are compared together, and if they're equal to each other, then the output will be that output that it has predicted with these chips here. So these chips here are running like something called a neural network processor, which is specific designed for like doing neural network calculations. So they're specifically good for doing matrix operations, because like they can be really fast when we're using hardware, and this is like why we create a neural network processor instead of just using an original like graphic processing unit. So like the neural network processor has this, like I talk about the ReLU and pooling here. It has specific hardware for those operations here, so like it can just be even faster with these kind of hardware for specific activation functions, and also like pooling layers and ReLU layers. And then the chips here does like 36 tera operations at 2 gigahertz. So it's really fast. Like it does like 72 tera operations per second. So it's like so many operations per second that it is like one of the fastest chips in the world, like when we're talking about neural network processors. And they have 2 of those processors here, so they have like 72 tera operations in total at 2 gigahertz. So they just have these 2 chips here running the same amount of tera operations. So it's a lot of tera operations running these neural networks, and then they just compare those 2 outputs to get the best and most precise output that it can get. So we're also going to talk here about the training process of the neural networks at Tesla here. So we have this Tesla car here driving around in the environment, and Tesla has a lot of cars driving around and just gathering information all the time when it's driving. So the car here is driving around, and we can see here that the cost view from the sensors and the cameras, and also like the neural network outputs that we have talked about already. So we have these kind of predictions here in the image, and this is like the data input to our neural network, and then we can see like the predictions here from the data input given to our neural networks that has already been trained a lot of times and like a lot of hours. Like Tesla states that the neural networks has been trained for more than 70,000 hours of training. So when we're driving around in an environment here, like we spot new situations that the car hasn't seen before and our neural network hasn't been trained on. So we can improve the training set with new images or like new situations. It could be like, for example, it couldn't detect if there were like a bicycle on the back of a car, or it spotted as a bicycle, and then it will like brake because it thought that a bicycle would drive in front of us and stuff like that. So like this is just like specific situations that Tesla can now like improve the data set or like training set on. And then they can label that data with like the new unknown data, so they can say like this image here is actually a car and not a bicycle. So it should be able to detect bicycles hanging on the back of the car, which is like a really essential and an important aspect, because else it will just like detect it as a cycle and like bicycle, and then it will just brake when it like goes closer to it, because we don't want to like run over a bicycle. So then we label the new data here and we feed it to our neural network here, or like our convolutional neural network, and then we just do the back propagation back in the back in the neural network, and we train the neural network. And then when the neural network has been trained for a lot of more hours, then we can deploy the new trained neural network into the car, and then the process will just like keep repeating, and it will get new inputs and it will get new situations that it hasn't seen before. It will label that input and train the neural network again, and then deploy the neural network. So this is just like an infinite training process that just keeps going on and on and on. So the more the Tesla cars are driving around in the environment, like the better their neural networks get, like the better autonomous car they will get. So it's just about like time and like training process and repeated training process that gets like the neural networks at Tesla better, and also like the car for self-driving. So Tesla also had to like make this. They announced this at the Tesla Battery Day, that they had to like make a total rewrite of their code, because before the cars like view had like this kind of two-dimensional view here, or like 2.5-dimensional view. So they hit like they got stuck at a local maximum where like they couldn't do more stuff, and they couldn't make it better because they just hit a local minimum, and they needed more complex like features and different kind of like observations from the images, which like required 4-dimensional. So they had to rewrite all the code and all the neural networks and do some of the training over again to like make it able to like have this like kind of like 4D dimensional, where like 4D is like just one, like before they had like this 2D here, so like all the images they were just like separate, where in 4D here like it is just like when we get into images it will like now be a sequence of images instead of just individual images. So before they had like at a 2.5-dimensional, so they just took in one image and then they did all the processing on that image, where now they have this 4-dimensional here, so they take in a sequence of images and then do the predictions on that. So it's more like a real time or like live kind of predictions, and so like all the situations like they just like stick together, and like they're more related to each other with this rewrite of code here, and then it just makes it easier, or like it just enables them to do more complex stuff with the neural networks and their autonomous driving. So it's actually like how Tesla derives depth in the images from vision alone.
Perception from vision alone, a classical approach, and two that rely on neural networks. So here's a video going down, I think this is San Francisco, of a Tesla. So these are our cameras, our sensing, and we're looking at all, I'm only showing the main camera, but all the cameras are turned on, the 8 cameras of the autopilot.
Like this is like how the 3D reconstruction
what you can do is you
works,
can stitch up
compared to like if they use LiDARs.
Using multi-view stereo techniques. So this, oops. This is supposed to be a video.
So you're just driving like through the road here, and then they're reconstructing the images like
so this is the 3D reconstruction of those 6 seconds of that car driving through that path. And you can see that this information is very well recoverable from just videos.
So one of the main aspects that is talked about like is why Tesla doesn't use LiDAR. We're like talking about like, for example, Google's Waymo and other like car companies that is trying to solve autonomous driving. Like then they're using LiDARs, and they have this big and huge and ugly LiDAR scanner on top of the cars. So a LiDAR scanner is just like it just sends out like infrared light to the surroundings, and then when the points or like the laser beams they hit an object, then it will reflect from that object and be sent back to the sensors, and then it can estimate all the distances to the points that it sends out in the environment. So this is like to give you an overview over like what the LiDAR scanner does. So like all these like colors is points that is like have like points that there gets an infrared beam sent to, and then it gets reflected and observed in the LiDAR scanner, and then we have a distance to all the points that it has sent out from the LiDAR scanner as well. So Tesla uses this like another approach here with the camera, and they say that it uses this because like the human being doesn't have like lasers that are just like sent out from the eyes. Like the human just drives the car with like only the vision. So like Tesla tries to like solve this computer vision like or autonomous driving by using a camera, and then when they're driving through and the environment, like they can actually like make a 3D reconstruction, as we can see here on the right. So like it's kind of like the LiDAR scanner, which like tries to like have a reconstruction of the 3D or like our environment. So Tesla does this approach with the camera instead, and also uses the radar to like do the depth in the image, and also like tries to calculate the distances to objects in the image as well. So Tesla have now like announced their full self-driving beta version, where like it is like their optimal goal to like have a car driving around by itself with no interactions by a driver. So like this is like we can see like the image views here for the cameras in the Tesla. So this is an intersection here with that Tesla can see from the cameras, and then it can reconstruct it and have this output down here, which is the output from the neural networks given those cameras here. So this is the new rewrite of the code here with the four-dimensional images. So they have this sequence of images that is taken in and does predictions on that. So we can see here that it all now like detects like an intersection here with all like the lines here, like the road lines, and also they have this dotted green line here, which is the path that the Tesla is going to take. And also like the text is the car here, like all those blue boxes here, like their cars, and also like purple cars. So they have like color indications for like different kind of situations. It could be like they have a green color indication if the car is going to follow that car, and some other color indicates like for example that the car is going in the opposite way of the Tesla and stuff like that. So this is like really useful, and this is like a crazy output that it gets from all the neural networks. So this is just like a combination of all the outputs from neural networks, and then this is what the car can see and what the car tries to like operate around when it's driving around by itself by using this full driving computer that we also talked about, and just all the inputs from its sensors and by the radar and the cameras, like the 8 cameras around the Tesla. So the last thing we're going to see an example of here is like how Tesla's shadow mode works and like how important it is. And it's also like it's just so cool that they have this type of shadow mode here.
A fast overtaking vehicle. So this is what we do when we initially have some algorithms we want to try out. We can put them on the fleet, and we can see what they would have done in a real-world scenario, such as this car that's overtaking us very quickly. And this is taken from our actual simulation
environment. Like this is exceptional
showing different
for
paths
the cars
that
keep
they're
learning.
taking, and how those overlay on the real-world behavior of a user. When you get those algorithms tuned up and you feel good about them specifically, and this is really taking that output of the neural network, putting it in that vector space, and building and tuning these parameters on top of it, ultimately a thing that we can do through more and more machine learning.
So we're now going to know like how the Tesla's neural networks they work, and I've shown you some different kind of examples of like how Tesla uses the neural networks to do some different kind of predictions, and how to use the camera and computer vision to like get an understanding of the environment that the car is driving around. And also like the training loop or like the training process, like how Tesla they train the neural networks on the cars driving around, getting new data information, and then feeding that information to the neural networks. So they just like keep getting better the more data and the more time that the neural networks and the cars get. So thank you guys for watching this video, and remember to hit the subscribe button and bell notification under the video. And also like this video if you like the content and you want more of it in the future. I'm going to do in the tutorial later on like how neural networks work more in depth. So if you're interested in one of those, like you can subscribe to my channel and you'll know like when that tutorial starts. So I'll see you in the next video, guys. Bye for now.